You are welcome to the Scholar online class. I'll be your physics tutor for today. My name still remains Abdulwasi, and our topic for today is going to be on electric field. And what we'll be looking at under this electric field, we'll be looking at concept of electric field, Coulomb's law, electric field strength or intensity, and electric potential. Now, to start with, what do you mean by electric field? Let's break the word together, the word I have there, electric, the word electric and the word field. When you talk about electric, we all know that it's related to what? Electrons. And that leads to what? Movement of electrons from one position to the other. Then when you talk about field, we can relate it to what? Our normal football pitch. A field, a region, where what? An event takes place. So if you now marry these two words together, electric and field, then we can define electric field as a region in space where the effect of what? Electric charge can be what? Can be felt. Or we can also take it as what? Is a region in space where the what? The effect of force can be felt on what? On a unit charge. So these are the ways we can define electric field. So under this electric field, under the concept of electric field, we'll be looking at what we call electric lines of force. Electric lines of force. Now we all know that if you talk about a unit charge, let's say we have a unit charge in this form. It can be positive or negative. When we talk about charge, we use the symbol Q. The letter Q to represent our charge. So let's say this is a unit charge now. If the work done in bringing this charge here from this point to another point here, then this line that I have here is what we refer to as electric lines of force. Because this line is what will pull the force from the position to another location. So electric lines of force are the lines that the path, or we can define as what the path that what a charge takes. Just like you have in your projectile, the path that what a charge passes or takes is what we call electric line of force. Now, that will not take us to the Coulomb's law, because according to a scientist, which we call Sir Coulomb, he propounded what? A law on the electric charge. And when we talk about electric charge here, we can either have it as positive or negative, just like I said earlier. This is a charge. This is also a charge. This is positive charge and this is negative charge. And both of them can occur in a space in region. It's just like talking about what the concept of what? Rubbing a pen that is dry on your forehead. And after you take it and bring it towards a piece of paper, the paper will be attracted. That's the simple concept of what? Of electric field. But here we are looking at Coulomb's law. What does it state? Now, Coulomb's law states that, let's say we have two charges, 1, 2. This is Q1, this is Q2. Then these charges are separated by a distance, let's say R. In some other context, we can use D. These two charges are separated by a distance R. Then we need a force either to pull these two charges together or to repel the two charges, because based on the law of electrostatic force, which states that what? Like charges repel each other. Unlike charges what? Attract each other. So based on that concept, if this is positive and this is positive, we need a force either to put the two together. But because they are what? They are like charges, there will be what? Repulsion. Likewise, if we have one is positive and the other is negative, also in this case now there will be what? Attraction, because they are what? They are unlike charges. So in both contexts, force is required. And that's why we call force is what? As a pull or push. So according to Coulomb's law, it states that in an electric field, the force of attraction between two charges, that is F, the force of attraction between two charges, the force of attraction between charges is directly proportional to the what? To the product. Product means what? Times. To the product of the two charges, that is Q1 and Q2. It's also propounded that what? But the force is what? Also what? Inversely proportional to the square of the distance between them. That is, F is inversely proportional to what? 1 over R squared. Let's say this is equation 1, this is equation 2. If you synchronize these two together, it means that we have our F is directly proportional to what? Q1, Q2, then divided by what? R squared. So this is what Coulomb's law says, that the force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And this is what we have. Now, you know that when you talk about inequality, anytime you have proportionality constant, you must remove the proportionality sign to what introduce a constant. So when we introduce our constant, it means we have what? Our F is equals to K Q1 Q2 over R squared, where our K is what we call electrostatic constant. Our K is called electrostatic constant. And as you can see on the board, the K has a value of 9.0 times 10 to the minus 9 Newton meter squared per coulomb squared. I repeat, K is equal to 9.0 times 10 to the minus 9 Newton meter squared per coulomb squared. So the unit of force here is what? Is Newton. The unit of our force, the SI unit of our force is Newton. That is N. And it means that what is what? It's a vector quantity. Now, let's now look at electric field strength or intensity. But before we proceed to that, I would like us to take one or two examples to verify what this Coulomb's law is stating. As you can see, from the body, you have the example. Example 1, still on what? On Coulomb's law. States that what? Two opposite charges of 12 microcoulombs and 8 microcoulombs, respectively, are 10 centimeters apart in vacuum. Calculate the force between them. So let's bring out the parameters, because one thing about science in general is that you must know where you are coming from so that you know where you are heading to. So the first thing is to bring out the parameters. We are given the charges. Let's say Q1 is 12 microcoulombs and our Q2 is 8 microcoulombs. Then the distance between them, 10 centimeters. That's R is equals to 10 centimeters. Now, mind you, our charge, the standard unit is coulombs. Then our distance, the standard unit is what? Meters. So all these microcoulombs and centimeters, we must convert to the standard unit. So this one in coulomb will give us 12 times 10 to the power minus 6 coulombs, because micro means 10 to the power minus 6. Likewise, this will give us 8 times 10 to the power minus 6 coulomb. Why this one? For the centimeter, you divide by what? 100. That means our R is equals to 10 over 100 in meter, which will give us 0.1 meter. So we are okay. So as you can see from example on the board above, we have example on Coulomb's law. It said two opposite charges of 12 microcoulomb and 8 microcoulomb. That is, our Q1 is 12 microcoulomb and our Q2 is 8 microcoulombs, respectively, are 10 centimeters apart. That is the distance between them. Our R is 10 centimeters. Then we have to calculate the force between them. So the parameters are Q1 is 12 microcoulomb, our Q2 8 microcoulomb. The distance is 10 centimeters. Just like I stated earlier, the standard unit for charge is coulomb. What is standard unit for your radius or distance is what? Meter. So you must convert all this. So these 12 microcoulomb is known as 12 times 10 to the power minus 6 coulomb, because micro means 10 to the power minus 6. Likewise, our 8 microcoulomb will give us 8 times 10 to the power minus 6 coulomb. Why our distance in centimeter, to convert it to meter, you divide by 100. That gives us 0.1 meter. So with all this now, then we are good to go. So from the formula, F is equals to KQ1 Q2 over R squared. Then substituting into the formula, we have our F is equals to, our K is given on the board, is a constant. That's 9.0 exponential minus 9 times Q1, that is 12 times 10 to the power what? Minus 6. And our Q2, that is what? 8 times 10 to the power minus 6 divided by our distance, that's 0.1 squared. So if you go through with this formula, we are F. What the basic thing they want to test here is what? How you operate or how you juggle with what? With the standard form. So what I will do is I will separate the numbers from the standard form. That is, I have 9.0 times 12 times 8 times 10 to the power minus 9 times 10 to the power minus 6 times 10 to the power minus 6 divided by 0.1 square give us 0.01, which is the same thing as 10 to the power minus 2 in standard form. squared or 10 raised to the power minus 2 in standard form. So if you go ahead with this now, we have this. So multiply these three together to give us 864 times 10 raised to the power what? Minus 9, that's minus 15 minus 21. Then times 10 raised to the power, according to the law of indices, when you bring this one, give us 10 raised to the power 4. So finally, we have our F is equals to 86.4 times 10 raised to the power minus 12, minus 4 give us minus 18. So based on the standard formula I have applied, so our answer will be this in Newton. So that is the force. It means that the force of attraction between the two charges is what? 86.4 times 10 minus 18 Newton. I hope that is clear. So let's quickly take the second example. The second example, from the second example, said what? An electron of charge minus 1.6 times 10 minus 9 coulomb orbits a proton with charge 1.6 times 10 minus 19 coulomb at a distance of 5.9 times 10 minus 11 meters. Then we are asked to calculate the electrostatic force of attraction between them. Okay, just like we did in the first one, we have to bring out the parameters. What are the given parameters? Our Q1 is given as what? 1.6 minus 1.6 exponential minus 19 coulomb. Our Q2 is also 1.6 exponential minus 19 coulomb. And our distance R is what? 5.9 exponential minus 11 meters. So all these are what are in their normal units. So we don't need to convert anything in this case. Now remember, when you talk about both electrons and proton has the same charges. The only difference is that electron is negative while proton is what? Positive. So applying the formula, we have our force F is equals to KQ1 Q2 over R squared. And that will translate to 9.0, that's our K, times 10 to the power minus 9, then times our force minus 1.6 times 10 to the power minus 19 times the second charge 1.6 times 10 to the power minus 19 divided by 5.9 times 10 to the minus 11 all squared. So if you calculate this, applying the same method, bringing the parameters together, that we have 9.0 times minus 1.6 times 1.6 times 10 to the power minus 9 times 10 to the power minus 19 times 10 to the power minus 19 divided by 5.9 raised to the power 2 times 10 to the power minus 22 when you multiply the powers here. So if you calculate this, invariably this will give us minus 6.62 times 10 raised to the power minus 8 Newton. So this is what? This is the force of attraction. So you can see that in applying Coulomb's law, it is a what? It's very, very straightforward. But the important thing you want to test is what? How you do with what? The standard form. To meet you in our next class. Thank you.